All right, everybody, welcome to the video here for the first Regents Review weekly assignment. So the goal of these weekly assignments is to provide you a concept that you should be able to do for the upcoming Regents exam. Each one of these reviews goes over just one concept. And in today's concept, we're going to be talking about dividing polynomials, something we haven't done since Unit 1. So a couple things, if it's multiple choice, you can always have enough space off to the side on the Regents exam to actually complete the problem. And when you're going through, just make sure that you're looking at your choices first. So, like, I noticed something right away about my choices here. They all have a different remainder. Include the negatives there too. So since they all have a different remainder, we probably actually could use the remainder theorem here to solve this pretty quickly. However, we're going to get a fraction number that we'd have to plug into the remainder theorem. So we're not going to do it that way. We're just going to go right to the whole division process here. You'll see the remainder theorem later on in this video. So to be able to do the division here, we're going to start by making our rows. So because our denominator is a binomial, we know that there's going to be two rows. So I'll put 2x and 3 off to the side. Now, the goal here in division, unlike multiplication, is we're actually trying to create this polynomial within the boxes. Now, this polynomial actually has a missing term. So the first term is 4x cubed. The second term, which is missing, is 0x squared. The third term is 5x, and our constant and last term is 10. Now, one of the reasons why we want to look at those choices is they all have remainders. So we know that the last box is not going to be 10. We're going to have to calculate and figure out what the remainder is. So the first thing I'm going to put into my boxes is 4x cubed. So that's going to be my first box. And then we have to think to ourselves, what could I multiply 2x by to make 4x cubed? And that would be 2x squared, which also tells us something. Since this is x squared, I need a column for the x term, and I need a column for the constant term. So I know I have 3 columns. Basically, the number of columns is always one more than this first exponent that we find. So now we can do some multiplication. 2x squared times 3 makes 6x squared. And these two boxes together have to equal our next term, 0x squared. So we need to add something to 6 to make 0. That would be negative 6. And we want those terms to be like terms, so we'll say negative 6x squared. And then we start the process again. So we say, what do we multiply 2x by to make negative 6x squared? Well, that would be a negative number. Positive and a negative make a negative, and just a 3x, which would make this negative 9x by multiplying, right? Negative 3x times 3 makes negative 9x. And then we could go to our next term we're trying to make, which would be 5x. So then we have to think, what could I add to negative 9 to make positive 5? Well, since I want to make it positive, I have to make a number bigger than 9. So we're going to go with 14 there. And we want it to be like terms again, so I'll make that x. Then we have to ask ourselves, what could I multiply 2 by to make 14? That would be 7. And this last box then becomes 21. So right away, before we really go any further with this, we could start looking at our choices, because our choices is the answer. So we know for sure it's not going to be choice C or choice D, because they have a 2.5 here in the middle, and we know that it's 3. And if we go a little bit further, we also know it's not A, because that's positive. We want it to be negative. So we kind of know this answer is already choice B. But just to make sure, let's find our remainder. So to find a remainder, we know that this last box is supposed to equal 10. So what we're saying is 21 plus some number has to equal 10. So if we subtract 21, we get a remainder of negative 11, which is what we got with the choice. So now we can write our final answer as 2x squared minus 3x plus 7. We can either do plus a negative or just put a negative like the answer shows. the remainder of 11 over what we divided by 2x plus 3. There's my answer. All right, let's move on to the next one. So the next one is similar, right? We can see that we're dividing, but unlike the first one, we have some of the same remainder. So I'm not going to be able to use the remainder theorem here either. We're going to have to just jump right to our division. So I want to divide by, again, a binomial. So I know that I need 2 rows. So I have x plus 2. And again, we're trying to create this. This is actually a little bit of an easier one. There's no missing term here. So we'll put x cubed in that first box. X times x squared would make x cubed, which again tells us we have 3 columns. Then if we go through our process, our next numbers we multiply are 2 and x squared. So we have 2x squared. And we need to add up to 2x squared. Well, then we have to think, well, what could I add to 2 to make 2? Well, that would be nothing. So 0, x squared, which would make this 0x. And that would make this 0x, because 0x times 2 would make 0x. Now, if you remember in class, some of you kept just putting the zeros in there. It's not a bad thing to do. I like putting the variables in as well. I know they mean nothing here, because 0 times x is really just 0, but I think it helps with the combining of like terms part. Like these two have to add up to x, so now I have to think how many x's do I add to 0x to make 1x? Well, that would be 1x. Then we have to ask ourselves, what do we multiply by x to make x? And that would be 1. 2 times 1 makes 2. And again, here we have a remainder. Because this 2 in the last box is not the same as this 6 number, we know that we have a remainder, which is good for us because we could cross off choice A and choice C, because those don't have remainders. So to find the remainder, again, we have to ask ourselves, what do we add to 2 to make 6? So we're saying 2 plus some number has to equal 6. And you could always probably guess at this number is 4. So we know that the remainder is 4. So choice B and choice D both have the correct remainder, but now we have to figure out which one has the right quotient. This number is our quotient up top. So we could say our answer is x squared. We don't have to write plus 0x, so we'll just skip that. Plus 1 plus 4 over x plus 2. So we get choice B here. Moving right along. All right, so number 3 actually is requiring us to use the remainder theorem. So it says, given the polynomial r of x, it's a cubic polynomial, it asks us to just simply find the value of r2. So r of 2 is asking us to plug 2 in for all the x's. So if I wanted to do r of 2, I would say 2 cubed minus 4 times 2 squared plus 4 times 2 minus 6. And then to find r of 2, I could just type that into my calculator. So we'll go to Desmos. So in Desmos, let's move this so it's out of my way. Okay, so we want to put our parentheses. So we have 2 to the power of 3. I'm just going to click back and forth here because I can't remember. So we have 4 times 2 squared. We have 4 times 2. You'll notice I'm plugging in exactly how I see it with the parentheses and everything, minus 6. So we get negative 6. Now that was the easy part of this question. The harder part is the second part. So the second part says, what does the answer tell you about x minus 2 as a factor of r of x? Explain. Well, if I'm evaluating 2, that's me saying that if I had x minus 2 as a factor set equal to 0, one of our potential solutions would be 2. That's what the remainder theorem is telling us to plug in to determine if this is or is not truly a factor. Well, the only way for it to be a factor, so for x minus 2 to be a factor, what would have to be true would be r of 2 would have to equal 0. Well, since it doesn't, we now know that it's actually not a factor. So what do you have to write here? So you can say because r of 2, we'll use the lowercase r here, r of 2 does not equal 0, we know x minus 2 is not a factor of r of x. All right, let's go to this last one. This last one's a little tricky. So this last one is mixing together division, it's mixing together multiplication, and it's mixing together this word identity. So whenever you see this word identity, that means you know whatever the equation is actually true. And what they want to know is what are the values of h and k that would completely make this a true statement. So why I say this is a little bit weird is they're giving us a polynomial and they're showing the product here, and we really don't want the product, we want the quotient. So I'm going to divide everything by that x minus 4 term, including this little k over here. That's going to cancel this out, right? That's going to reduce that to 1. And it's going to leave us with this whole side of this equation as 2x squared plus hx plus 3 plus the remainder of k over x minus 4. So this is our quotient when we divide the polynomial by x minus 4. So really all this is asking you to do is divide it just in a tricky way. So let's do some division. So we know that the denominator is x minus 4. So that's going to tell us we need 2 rows again. And we're trying to recreate this polynomial. So we'll say 2x cubed. What do we multiply x by to make 2x cubed? Well, that would be 2x squared, which tells us, again, 3 columns. We need a negative 8x squared here. And those 2 boxes have to add up to negative 10x squared. Then we have to ask ourselves, what do we add to negative 8 to make negative 10? So that would be another negative 2, which would make this negative 2x. Negative 2x and negative 4x makes 8x. And we want the x's to add up to 11. So then we have to ask ourselves, what do we add to 8 to make 11? That would be 3x. 3 times x would make 3x, so we put a 3 up here. And 3 times negative 4 is negative 12. Now, we don't want negative 12. We actually want negative 7. So we have to say, what do I add to negative 12 to make negative 7? So we'd say negative 12 plus some remainder is equal to negative 7. So if we add 12 to both sides, we then get a remainder of a positive 5. So let's write our answer. So our answer is 2x squared minus 2x plus 3 plus 5 over x minus 4. Now, to get the full points for this question, you have to identify and actually tell me and state what h and k are. So it looks like h got replaced by negative 2. So h is negative 2. And it looks like k got replaced by positive 5. So k is positive 5. So is this a division question? Yes, it's kind of just like a division question in disguise. Hopefully you tried these on your own first, and then you were just checking your work here, maybe got stuck somewhere and needed it. And I'm hoping that this video helped. Get ready for your weekly quiz.